Creating QGIS plugins, Landsat Temperature Calculator. Hello guys. This is a step-by-step guide to building a LST plugin for remote sensing analysis. Plugin overview. This example plugin calculates land surface temperature from Landsat 8 thermal infrared sensor, Hertz band 10 data. It implements the scientific workflow. Start with the compute top of atmospheric TOA radiance, then convert to brightness temperature BT, but it extracts LST just simplified, ignored emissivity. Then style results with a thermal color ramp. Plugin structure. The plugin contains these essential components: the folder LST_calculator, which includes icon.png, plugin icon, metadata.txt, plugins metadata, init.py, plugin entry point, and the main plugin logic LST_plugin.py. We can create the plugin directly inside the folder of plugins of the software, or we create a folder with the required files and zip it, then install it. In settings, user profile, open active profile folder. In the default, Python, plugins. Inside plugins folder, we create a new folder. Right click, new folder. We name it LST_calculator. Enter. You open the folder with the Visual Studio Code. Files, open folder, paste the path, plugins, and we select LST Calculator. Start with the creating metadata.txt. Inside the folder, right click, new file, we name it metadata.txt. Enter. Then we added the following information. For example, name of the plugin, LST Calculator, email of author, my email, name of author, QGIS minimum version, description, the version of plugin, about this plugin. Ctrl S to save. Then we create init.py. Inside the folder, right click, new file, init.py, enter. Inside init.py, we added from .lst plugin import LST calculator, define class factory, iFace, and return LST Calculator iFace. Ctrl S to save. Now we create the main file, right click, new file, LST underscore plugin dot py, which is core functionality. Inside the file, we start with the plugin initialization. Inside LST plugin, class LST calculator, define init self.iFace equal iFace for QGIS interface reference, self.action equal none for plugin toolbar icon. Then define init GUI, create toolbar icon and menu entry. Icon path equal os.path.join os.path.dir name file, which is icon.png. Self.action equal q action q icon path LST calculator. Self.action trigger.connect self.run self.iface.add plugin to menu LST tools self.action self.iface add toolbar icon self.action. The main workflow. Define calculate LST self band 10 path. Try first load LST band 10. Band 10 layer equal QGIS raster layer. Band 10 path, band 10 row. Next step, compute TOA radiance using ML multiply by B10 values plus AL. TOA layer equals self.calculate TOA band 10, 0.0003342, 0.1. After that, calculate brightness temperature. BT layer equals self.calculate BT, TOA layer. Visualize results. Self.style thermal layer, BT layer. QGIS project.instance.edit map layer, BT layer. Exception as E for errors. Self.handle error E. TOA radiance calculation. Diff calculate TOA. Self band layer ML and AL, which calculate top of atmospheric radiance. The formula ML multiplied by 10 plus AL, where ML equal radiance multiplied by 10 from MTL, while AL radiance added band 10 from MTL file. Enter equal self.create raster entry, band layer B10, formula equal F ML multiplied by 1 multiplied by band 10 plus AL. Return self.raster calculation formula, entry TOA radiance. Brightness temperature conversion. Define calculate BT self, TOA layer, which convert TOA radiance to Celsius. Formula K2 divided by ln K1 divided by L plus 1. Then minus 273.15 for converting to degrees Celsius, where K1 equal 774.89 for Landsat 8 constant and K2 equal 1321.08 for Landsat 8 constant, while L equal TOA radiance. We define the formula, then return self.rasta calculation using formula. Self.create rasta entry TOA layer. Use TOA layer and name it brightness temperature. Now, thermal color ramp styling for visualization. Define style thermal layer, color scheme, 20 degrees Celsius blue, 32 cyan, 40 green, 50 yellow, 60 orange, and 70 red. Then create renderer and apply to layer. Renderer equal QGIS single band pseudo color renderer, layer dot data provider, number of bands, raster shader, and layer dot set renderer, then trigger repaint. This is the full text of LST plugin.py, which is the main file in the plugin. Then we paste the icon inside the LST Calculator folder. Now, after we restart our QGIS software, we can see our plugin is installed. We click on plugins, manage and install plugin. This is our LST Calculator created plugin. And the better way for installation, we can create LST Calculator folder outside the plugins folder of the software, and we zip it. Let's name it LST Calculator 7-zip. Then we open QGIS software. We click on plugins, manage and install plugins. We choose install from zip. Select zip file, LST_calculator. Then click on install plugin. This plugin from untrusted source. Yes. Plugin installed successfully. We go to installed plugins. Click on LST Calculator. And this is the icon of LST Calculator. Let's run it. Click on it. Then the next step is select LST band 10 TIFF. This is Landsat band 10. That's it. Successful LST calculation. For example, we can change the color and we can export it, save as, and change pixels outside the study area to NA. For example, from -200 to 0, we change it to NA data. File name, PT, from my plugin. Now the outside of the LST image ignored and changed to no data. For example, you can check some different land use classes, the value of lake, water of lake, 20. This area has high degree, 42, and mountainous area, which may be covered by snow and ice, around 3 degrees Celsius. The methodology can be improved by correction of NDVI-based emissivity.